Intro to Magnetism, EM Spectrum, and Waves. Hi, I'm your first speaker today, Gabriela Longoria, and I'm covering the first part of magnetism. First up with magnetism, we have dipoles. A dipole is a pair of electric charges. We can use positive and negative, or north and south, separated by a small distance. However, the poles of a dipole do not line up with Earth's poles. The magnetic poles of a dipole are the opposite from the poles of Earth. So in this picture above, we have the Earth and we have a magnet on the other side. On the Earth, let's say the top part is north and the bottom is south. It's different on a magnet or on a dipole. On a dipole, the top part is south and the bottom part is north. An example of a dipole would be H2O or water, because the positive and the negative charges in the element bond them in the small space they occupy. So let's look at this water particle we have on the side. Now, the oxygen particle is positively charged. So the two hydrogen sides, the bottoms of them that connect with the oxygen, they're negatively charged, which is what bonds them together. Next up, we have magnetic field lines. Now, magnetic field lines, they are invisible or imaginary lines. They're used to represent the way the magnetic field works. They also show magnetic field and its direction. An example of this would be like the picture above, the first picture at the top, where it shows iron shavings or iron fillings surrounding a magnet. Now let's say the left side over here is positively charged, or it's north, and this side is south or negatively charged. So all of these fillings, each filling takes on the property of a magnet, where the top is north and the bottom is south, or vice versa. So with this, they all connect to its opposite, because like poles repel, they don't attract to each other. So with this, you can see them outlining the way a magnetic field works. A magnetic field goes in a sort of elliptical orbit, sort of the way the Earth does. And an even clearer image of it would be at the bottom, how they all basically just revert all the way around in type of a circle. How south goes to north and north goes to south. Magnetic flux. The measurement of the total magnetic field which passes through a certain area. It's useful for describing the effects of magnetic force on something in a given area. An example of magnetic flux is Earth's own magnetic field. It starts from the core, and it comes out in many lines that protects us from the harmful dangers of space, like dust and asteroids. It essentially keeps us in a bubble. And now on to Cutter for the second half of magnetism.
So, magnetic domains. Domains are like a region inside of an iron-like object. When exposed to a current, the domains will straighten, making an object more magnetic. So, like a piece of iron, right? They have these little indentions on the insides, and each one has been assigned a specific pole, so it's a north or a south pole, and each one has their own specific pole. When assigned to a current, those poles will go from pointing every different direction to straightening out, making north go one way and south point the other, therefore magnetizing the piece of iron. Now, next up we have ferromagnetic and paramagnetic. Ferromagnetic means a material that is able to be magnetized. It's easily able to be magnetized. It is highly affected by a current drawing inside of it, and the materials that can be affected that are ferromagnetic contain things such as iron, cobalt, nickel, and etc. So basic anything that's metallic that you would normally be able to pick up with a magnet. Now, things that are paramagnetic tend to magnetize for fairly shorter amounts of time. So while they can still be magnetized, they don't stay magnetized for as long. they're weaker to magnetic forces. So if you were to apply the same charge as you would to a ferromagnetic object, the paramagnetic object would not stay magnetized for as long. And now I'm going to introduce you to the EM spectrum, otherwise known as the electromagnetic spectrum. Now, the electromagnetic spectrum is a range of all parts of EM radiation, which is electromagnetic radiation. Now, you can read it from left to right or right to left. Just know that things on the right side have a high frequency, and the radiations on the left side have a lower frequency. There's also points fairly tiny right in between, basically right in the middle, which is visible light. And that's the type of radiation we can see, so our colors. Our RGBIV. So now I'm going to introduce you to Sebastian, going over the 3 different types of waves.
Hello, my name is Sebastian Garcia, and we're going to be talking about types of waves. We have 2 different types of waves, mechanical waves and electromagnetic waves. Mechanical waves need a medium to transfer energy. A medium is any such matter, such as air, liquids, gases, or solids. There are 2 types of mechanical waves, transverse and compressional. Compressional also goes by longitudinal waves. Electromagnetic waves do not need a medium to transfer. Electromagnetic waves are made up of 2 different types of fields, magnetic fields and electric fields. Examples of electromagnetic waves are radio, microwaves, gamma, UV radiation, and visible light. Transverse waves travel up and down, creating the iconic image of a wave. Waves that are transverse waves are actually ripples of water and vibrations. Compressional waves move forward and backward along the same direction that the wave is traveling, giving us sound and earthquakes. Now, transverse waves have the crest, the top, the very top of the wave, and the trough, the very bottom of the wave. Now, the way that they measure wavelength is by crest to crest or trough to trough. Now, compressional waves have the compression, where they compress, and the refraction, whenever they're extended. They measure the wavelengths by compression to compression. Now, period and frequency. Frequency is how often an event occurs. In this situation with waves is how often the wave is how many waves are traveling during a short period of time. Period is the amount of time it takes for the event to happen. Frequency is measured by the number of waves that passes by each second, and the unit of frequency are hertz. Thank you very much.